Hello, today we're going to be implementing an animation system in Raylib. This video is not going to be a how to set up Raylib video, so if you need help setting up Raylib, I made a video on it in the past, which is linked in the description. So go ahead and check that out. It's only the first few minutes of the video, and once you are done with that, you should be able to create and run your own Raylib application. This video is also not going to be a C or C++ tutorial, so I'm kind of assuming you know the basic syntax and the general paradigms of the language, but I will be sort of thinking out loud because I find that thinking out loud is extremely important whenever teaching or learning anything, so just keep that in mind. But without further ado, let's go ahead and look at what we have to start out with. So I have a skeleton Raylib project here, but what I mean by skeleton is I don't even have a CPP file yet. I just have the Raylib header file, and I have the Raylib static library file, and I have a make file, which all of this is, by the way, linked in the description. And we're just going to create our first file and get started with this. So I'm going to create my main.cpp file. And let's go ahead and just make our boilerplate Raylib application. So let's see, we need to have our entry point for our C++ file here, and we need to actually include Raylib to make this a Raylib application. Now, in order to make this a game, we need to do three things, which is create the application, start and run the main loop, and then close the application. So I'm going to put a init window, which will initialize the Raylib context and the OpenGL context and open a window with glfw. So we'll do 600, 400, and then like animation video. That's going to be the name. That's going to be the title of the window. I'm doing 600 and 400 because I am making a video and I don't want it to take up too much space on my screen. Now, as is a common pattern in the Raylib world, whatever is created must be destroyed. And so whenever we initialize the window, we should make sure that we are also closing the window. So now all there's left to do is to create the game loop. And the game loop, we can just do that by making a while loop here, and then the condition is just going to be while not window should close, so while the window wants to stay open. And then basically the inside of this scope is going to be what happens every single frame. And so for this, we're just going to do our begin drawing to begin the render pass, and then the end drawing, which is going to end the render pass. And in here, to make sure everything's working, I'm just going to put a clear background here and throw in that sky blue color. Okay, let's just switch over to a terminal and run that make file and test to see if this program will work. So let's do that. And as you can see, we have a 600 by 400 window with the title animation video and a nice sky blue color. So perfect, awesome. Now, the first step in actually doing what we want to do, which is, make an animation system, is to actually load in a texture and draw it. So I'm going to do that here by creating a new texture 2D variable. I'm going to call mine player idle texture because I'm going to be animating an idle animation here. For the function that actually loads in the texture, if you're new to Raylib, basically the idea behind Raylib is that it's extremely simple to use. So if you think about the task that you want to do in English, there's a pretty good chance that that task will actually just have a function that literally is just the English that you just said. So for example, if I want to load in a texture, I'm just going to type in load texture. And if you have like a modern text editor with autocompletion, you should see that we do have these suggestions like load texture cube map, etc. So I'm going to load the texture here, and this expects a file name here. Now I have to actually make sure, I have to actually check what the file name is. So I'm going to open up my file browser here, and it's going to be inside of assets, inside of heroes, and I'm looking for an idle animation here, which is hero char idle anim strip 4. That's kind of a lot, so I'm actually going to copy that file name here, go back over here, then we're going to be going into assets, going into heroes, and then pasting in that name here, and that should be our image loaded in like that. And as I said before, since we've loaded it in, we should unload it, so I'm going to put unload texture here and pass in the player idle texture to specify which texture we're unloading here. It's important to note that I'm loading in the texture after we have called init window because we can't load in a texture before we initialize the OpenGL context because we need to have the global OpenGL context in order to create a texture. Okay, so now to make sure that that works, I'm going to actually draw the texture. So I'm going to do draw texture here. And as you can see, there are many options. I'm going to choose the draw texture pro because we're going to need this one whenever we're actually doing the animation system. So might as well start early. So I'm going to do draw texture pro here. Takes a lot of arguments. I mean, it is the professional one. So, what do you expect? Let's just pass in that player idle texture. And for the source, I want the entirety of the image. So I just want to go from the top left, which is going to be 0, 0, to the bottom right, which is going to be player idle texture.width and player idle texture.height. For the destination, I want something that's big, that shows up on the screen well. So I'm going to put like, I'm gonna make it 1010 so it's not right up against the edge of the screen. And then for the width and height, I'm just gonna put like 100 and 100 here. For the origin, this is the actual like coordinate of which we rotate around. And for us, I'm just gonna keep it at 0, 0 because we're not gonna cover rotations in this video. In the same vein, we're just gonna keep the rotation at 0. And then for the color tint, we don't want our image to have any sort of tint. So I'm just going to put white here and we should be good to go. Oh, and also since the height and the width are integers, we need to typecast them to floats. Okay, now let's recompile our application and run it. And we should see that we have our sprite here. It is 10 pixels over, 10 pixels down, and 100 pixels wide and 100 pixels tall. But the actual image had an aspect ratio of like 4:1, so it's gonna look pretty smushed here. If I made this like 400 by 100, then it would look like the normal width, but we're not going to want that because later on, we're going to be only showing one of these frames at a time. So now that we have the prerequisites done, we can actually implement the animation system. So I'm going to create a new typedef struct and I'm going to call this my animation. And then inside of here, we have to think about what do we need to actually keep track of for an animation. And I think that we need a couple things. So the first thing is we need the index value of the first frame in the animation. So int first. We also need the index value of the last frame in the animation. So int last, like this. And if you don't know what I mean by the index value, think about the animation as if each frame was a number and they were all in an ordered list. So if I just rerun my application here, you can see that we have 4 images here. They're a little bit small, I'm sorry about that, but the first one would be index 0, then 1, then 2, then 3, and then if we went to the next line here, it would be 4, 5, 6, 7. You get the idea. So basically, that way we can just store whatever current frame we're on as a simple singular numerical value. So I'm going to have first and last here to cover that. But we also need to keep track of what our current frame is. And so for that, I'm just going to make a cur variable here, you know, wonderful naming schemes that I have. And then we need a couple more things. So we also need to know how fast this animation should go. So I'm going to put a float here, and this is going to be our speed. We also need to know how much time we have left on a given frame, because whenever we're doing this sort of stop motion style stuff, we need to know how much time we have left until we switch over to the next one. I'm going to type in float duration left. All right, and that's all we really need for a very, very basic animation. But this is just data, and we haven't done anything with the data, so it's useless to us right now. What we need to do is we need to implement a couple functions that will make some use of what we just wrote down. And so those two functions are going to be the update function and the retrieval of the frame function. So for the update one, I'm going to call it, I'm gonna say that it's void animation update. And I'm going to do C style functions here for those of us that are working in C. If you want to just make these methods of the struct or of the class, go for it, same thing, whatever. So we're going to do animation pointer, and we're going to point to the target animation. And then we want to create the function that actually retrieves the current frame that we're on. So this is going to be rectangle. So this is going to return the rectangle, which is going to be the source rectangle that we're retrieving. And then I'm going to put animation frame. This is going to have animation self like this. And as you can see, now we have both of these skeletoned out. I like to do things easy to hard so I can like feel a little bit more accomplished before I tackle something that'll take a long time. So I'm gonna do the easiest one out of these two first. That's going to be for me the animation frame, because that's only really a tiny little bit of math, whereas the animation update could be a little more challenging for some people. So the first thing we need to do is we need to convert the index into a top left coordinate, meaning that we need to convert this index value into the pixel X and pixel Y coordinate of the designated image. And the way you do that is you have to actually know some additional data about the image that you're working with. And as you can see, our animation struct does not have this data because I like to keep animations agnostic to whatever image they're working with. So you can essentially just apply them to whatever image you want. And so here in the animation frame, I'm going to actually specify another value, and this is going to be the number of frames per row. And this is going to be basically like how many frames are on each row of our tile set. In the example that we have with our own little idle animation, there were just 4. So this number would be 4 here. But there are some bigger ones like the Minecraft one that would be like 16 or like 64 or whatever. Now, in order to get the pixel X and the pixel Y of the current frame, we first need to get the tile X and the tile Y. And so I'm going to first grab the X value by saying float X equals, and this is going to be self arrow cur, and this is going to be modulus divided by the number of frames per row here. In order to do that for the Y, you just change this variable to Y and then change this from modulus to slash. Now, if you don't know about the modulus, basically just think about remainders whenever you're doing division. It basically just takes the remainder of whatever. So like 10 divided by 3 would be 1. So that kind of stuff here. And so this is going to be, this is how you retrieve the X and this is how you retrieve the Y. It's a very, very common thing in game development to convert an index to a coordinate. So memorize this if you can. But this is currently in tile coordinates and we need this in pixel coordinates because that's what we're rendering on the screen. So I'm going to wrap that in parentheses and then I'm going to multiply that by our tile size. And our tile size on the actual tile set, not to be confused with our display tile size, the actual pixel, size of each tile is 16 on this one. So I'm going to put 16 here. If you're a good programmer, you would pull that out into a global variable so that you are not just repeating yourself a million times, but I'm not a good programmer. So let's go ahead and do 16.0 like this. And we're getting a complaint here, which is result of integer division using a floating point context, possible loss of precision. Yeah, whatever. I mean, you can just do that, and C allows you to do whatever you want with typecasting. So now we want to actually return the frame, which the frame is literally just the rectangle. Because remember, this is all we need to do is essentially just crop out a little piece of our tile set. So I'm just going to return our rectangle here. And for the X value, it's going to be that X value we just made. For the Y value, it's going to be that Y value we just made. And then for the width, it's going to be the tile size, so 16.0. And for the height, it's going to be the tile size, like this. Okay, awesome. So you're halfway done. That is how you get the animation frame. If an animation can't update itself while the game is running, then is it really an animation? I don't think so. So let's go ahead and actually implement that animation update. And the way that we do that is we basically subtract the change in time from the previous frame to the current frame and subtract that from the duration left until there is no more duration left, of which then you increment the index until you reach the limit, and then you decide what you do when you reach the end of the animation. So that was a lot of information. Maybe just writing it out will be a little bit easier. So the first thing we want to do is we want to get the delta time, and the delta time is given to us by get frame time, which is provided in the Raylib API. And from that, we can then subtract from the duration left. So we can say self arrow duration left minus equals delta time. And then what we want to do is we want to check if we don't have any more duration left, because then we need to go to the next frame. So we'll say if self arrow duration left is less than or equal to 0. If it is, then what we want to do is first we want to reset the duration left, because when we go to a new frame, now we should have a full duration to progress over. So this will be self.duration left equals self arrow speed. The next thing that we want to do is we want to increment the current index. So we'll say self arrow cur plus plus like this. But whenever we reach the last index, which for us is going to be 3, and then we go up to 4, that would be bad. We would not have the correct result. So we need a way to actually handle whenever we reach the end of the animation. And what we can do is we can just say like if self arrow cur is greater than self arrow last, basically saying if we've reached the end of the animation, then, if we are repeating, which I'm going to do repeating just to start out with, then we want to just reset current. So we'll say self arrow cur equals self arrow first, effectively putting us back at the beginning of the animation. And if that's all we're doing, then we're done. We have implemented a simple repeating animation. So let's go ahead and actually use it here. I'm going to create the animation here. So I'm going to say animation anim, and I'm going to create a new animation like this, which will have dot first. And for dot first, I'm going to put 0. Dot last is going to be 3. Dot cur is going to be 0. So we start at the very beginning. The speed is going to be equal to 0.1, and the duration left is going to be equal to 0.1. Now, instead of just displaying the entire image all at once, we can just get rid of that and then just use that animation frame function here and pass in the animation. And then for the number of frames per row, we know that to be 4. But this wouldn't actually move at all because we need to update our animation every single frame. So before they begin drawing, I'm going to put animation update here, pass in our animation, and now we should be good to go. If I run make and then I run main, we should see, so I think it has something to do with the rounding here. I'm going to change these from floating point values to integer values like this. And then we can just get rid of this floating point conversion here. And then we need to now typecast them at this point like this. And then if we run make and run main, we should see that, yes, now we have the proper animation. That was some issues with trying to treat integers as floats and vice versa, which can have inconsistencies, but now we should be good to go with this animation here. Now, if that's all you need to do, then great, you can stop watching the video, you're all done. But maybe you want to have animations that only execute once, and then they just hold the last frame at the end. And so for that, we need to actually introduce different types of animations. Now, in order to do that, I'm going to create a new enum, and this is going to be our animation type enum. And this is just a nice way to make, type identifiers readable. And for us, we're going to have repeating animations, which I'll just set to 1, and then I'll have one-shot animations, which I don't know if that's the correct term for them, but basically animations that only execute once and they just stay there at the ending state. And so now inside of our animation, we're going to add some new data, which is going to be the animation type. And I'm just going to call this my type variable here. So now what we do is in the animation update here, instead of just automatically, setting it back to the beginning, what we would do is we would switch on this type. So we'd switch on self arrow type. And if we are repeating, then we want to do what we were doing before and just reset it to the beginning. And we also want to add a break statement here. But you'll see that my LSP is being very nice to me. It's saying that we need to also handle one shot. And so whenever we are a one shot animation, then we want to simply reassign cur to the last frame and then run break like that. Oh, and I forgot that I am not in Go, sorry. I put the case before there like this, and now it should be working. Okay, and so, before we make a critical mistake here, we also need to specify the animation type. So I'll put .type, and for this one, I'm going to put now one shot. And so now if we run this, we should see that this will actually run the animation only once, and then it will just be still at the last frame afterwards. And that was exactly what we saw, maybe if you were able to catch it, but it was really quick. So let's go ahead and add a little bit of functionality where whenever we press the space bar, it resets the animation. In order to do that, I'll just say if is key pressed, key space. And then if it's pressed, then I'm going to do anim.cur equals anim.first. You could wrap this in a function or a method if you're not comfortable with just assigning the cur value directly, but I'm kind of programming like I'm in C land and I like danger, so we're just going to put it here directly like this. Now if we run make and run main, we should see that every time we press the space bar, we now get the animation playing, which is cool. This is great for like jump animations and those sort of things that only need to execute once. You don't want to be repeating your jump animation while you're in the air, stuff like that, Okay, and so now what if we want animations that go backwards? Well, it's actually kind of easy to implement. All we have to do is instead of just only incrementing by 1, we can add something new, which is going to be our step. And basically think of step as like, how far are you stepping to the next frame? So far, we've had a step of 1 because we're just going 0, 1, 2, 3, But if we had a step of 2, we'd be going 0, 2, 4, 6, etc., etc. And we can use this, and we can also have a negative step. So we could have -1, and we could start going backwards on an animation. Now, what I will say is this is going to be committing a code war crime, and that's because in order to have this work correctly, we need to just essentially duplicate some code here. So I'm going to actually copy this if statement, and then just swap it from greater than or equal to less than or equal to. And then I'm going to copy this switch statement here, and I'm going to paste this here. But instead of first, I'm going to put last here, and then instead of last, I'm going to put first here. We also need an else if right there. So yes, I am duplicating code, which violates dry, but you know, sometimes it's okay. And this is one of those times where I think it's acceptable to repeat yourself. You could pull this out into a function if you want. I don't think it's that big of a deal. So first thing I'm going to do is I'm going to say that the step is equal to 1 on this original one, and then I'm going to copy this animation, and then I'm going to paste it here, and I'm going to call this one animation 2. But this one is going to have a cur of 3 because we want to start at the end of the animation, and it's going to have a step of -1. It's going to be repeating. I'm going to change them both back to repeating for demonstration purposes. So repeating and repeating like this. And now we're going to make 2 draw calls. So I'm just going to copy that draw texture pro. I'm going to paste one here, but I'm going to change this one to be at like 130, why not? So it's at X value of 130 here. And then instead of using the anim 1, we're going to use the anim 2 for this one. And then I'm going to make sure to update my animation 2 as well here. So I know that was a lot, like really quickly, but basically I just duplicated all the code that we used for animation 1 and did it for animation 2. So now if we run make and we run main, we should see, oh, and I also made a mistake here. It should be self arrow first here. And then also, instead of doing cur plus plus, it needs to be cur plus equals self arrow step like this. Now if we rerun it, we should see that we have one animation going forward and one animation going backwards like this. You can see by the waves in the cloak which way they're going. You know, this one's going backwards, this one's going forwards. So there you go. Now we have reverse animations, reverse one-shot animations, regular one-shot animations. You have 4 types of animations implemented in this pretty small amount of code. Now, if you're wondering like things like, oh, how do I handle like turning around and stuff like that, which aren't quite animations, it's actually pretty simple. All you do is hold the direction of the player. And so what I would recommend doing is I would recommend creating an enum called like direction here. And this would have left equal to -1 and then right equal to 1 here. And then what you do is inside of the main function here, we essentially just hold on to the state of the player by saying like direction player direction, and I'm going to assign this to left here, which means that this is now going to be equal to -1. And all we need to do to ensure that the player is facing the correct direction is pull out the animation frame. So I'm going to say like rectangle player frame equals this function call, and then we would just say player frame dot width times equals the player direction, and then we would just sub in that player frame for where we had that function call originally, and that's all we need to do. Now we can just go over here and we can just add some if statements. So we can say like if key A was pressed, then we want to set the player direction equal to left like this. Otherwise, if we press the key D, then we want the player to be facing right. And that's all that we need to do. So we can just run make and run main. And if we press D and A, as you can see, now the player is moving left and right when I'm pressing A and D. And the way that that works is that the direction is actually, you know, -1 when it's left, which just flips the width into the negative. And whenever you flip the width of the source rectangle to negative, it actually flips it visually on the screen, which is really, really convenient because that means that we can then display our things mirrored on the Y and the X axis if we need to. I don't have enough time in this video to do it a proper system for the entire animation like suite that you would need for a player. But basically for a lot of people's situations, you really don't need anything too crazy. You basically just have like a few categories of animations. So you'd have like your idle animation, and then you would have your running animation like this, right? And you would also have like your attacking animations and these sort of things. And you would maybe have some sort of like jumping animation. And essentially what you want to do is, I would really recommend drawing it out if it's like your first time, or if you just have a complex animation system. But you basically just say like, you know, are the keys pressed to go into running? Then you're running. If you're jumping, then you want to leave the running state, right? If you're jumping, then you can't go into your idle one. So this one, you know, cannot exist. You can't have a transition here. You also might not want to be able to attack here, so there might be like no connections here, but you could attack while you're running possibly, and you could attack while you are idle. So basically, like, draw out a little mental model like this, and then try to implement this, you know, initially just using like a crap ton of if statements, and then maybe try to implement something a little bit nicer with some pattern matching and some switch statements and all these cool little tricks. My biggest tip for this is enums, enums, enums. If you can get everything done with enums, then do everything with enums. That's why I use animation type here instead of just storing a numerical value, and that's why I use direction here instead of storing a numerical value. It makes it more clear to you, and it makes it more clear to you a month from now when you have no idea what you wrote a month ago. So keep that in mind, and good luck to you in your adventures. But otherwise, thank you very much for watching. Hopefully you'll learn something new. If you are an aspiring developer, or you're a developer and you want to join a community to talk to other people in the scene, or you just want a place to ask your questions about this video, feel free to join my Discord, which is linked in the description, where there is me and a bunch of other people that would be glad to help you with these kind of issues. Also consider supporting me on Patreon so I can continue making videos like this. Thank you very much for watching. Have a good day. See ya.